Good evening, everyone. I'm Jyoti Sharma, and I welcome you to week two live session that will be from 6 to 8 p.m. Uh, this is a brief introduction of myself that right now I'm a PhD final year student from ISO Bhopal, and because right now I'm a PMRF research fellow, that's how I have the responsibility to teach you people on this live session. And again, I'm telling you how we will proceed. So I have a lot of MCQ questions. So along with that MCQ, I also have MSQ, that is multiple select questions. So you need to select more than one option, and then we will try to find out the solution of it with the discussion. And your participation is highly valued. So how you can participate? You can write in the chat box whatever answer you are thinking is the right, or even if you have any doubt, you can ask me while writing on that chat box, and that's how I will try to respond you as soon as possible. Okay, so in week one, what we tried to cover is what's the difference between weather and climate. Then we moved to climate change. Then we wanted to move to climate extreme, but we couldn't. So today I have few questions on climate extreme, and we already have covered the summary. So I will not go on to the summary part, but along with that, we will touch heat wave and cold wave. What's the difference between these two, and how we define the heat wave and cold wave. Then precipitation extreme. So the extreme can be a flooding situation or even as the drought condition. So we will see the definitions of this precipitation extreme. Then we will study tropical cyclone. So this we will try to cover today in this live session. So I'm starting with the climate extreme, and then we will move on to the example of climate extreme. These are heat wave, cold wave, precipitation extreme, and tropical cyclone. So we will cover these one by one. Um, Before that, yeah, one question was left last week. So this question was, which of the following is included among the key greenhouse gases? And you have four options: hydrogen, helium, nitrous oxide, and neon. You can write in the chat box whatever answer you are thinking, right, so that I can know how many of you know the right answer, and with what speed I should proceed further. Okay, so I got two responses. Can I get more response? Which of the following is included among the key greenhouse gases? Okay, so I got the response C from two students, and yeah, so the answer is nitrous oxide. Uh, can you list out key greenhouse gases that you have heard the name of these greenhouse gases? The very important greenhouse gas that you have learned is, yeah, CO2. Along with that, I got response that CH4, that is methane. Then water vapor, yes. Um, More gases. Can you tell me more? Anthropogenic gas. So these are basically natural gases, but can you give me the name of anthropogenic gases that are greenhouse? Okay, so I got one response, that is CFCs, chlorofluorocarbon. Yeah. Okay. So what we have learned is that, let me take the pen. Okay, so we have CO2, that is the greenhouse gas, then CH4, methane, then we have water vapor, then we have um, SF6. Have you heard the name of SF6? Then we have N2O, that is nitrous oxide, and we have a lot of CFCs. So CFC is not just a one gas, but this is the category of the gas in which we have thousands of gas based on how many chlorine we have, how many fluorine we have, how many hydrogen we have, and based on that there will be different chemical formulas. So all these kind of gases will be considered into CFCs, that is the chlorofluorocarbon. Okay. Now the question is, we have two different questions. That is the in the warming in the warming which gas has more contribution or most contribution? uh, I got one question that are CFC's gas are more ozone depletion. Yes, you are right. That whenever we have fluorine and we have chlorine, so these are very reactive element in that compound, and if such compound will reach to the stratosphere, then it will react with the ozone and it will cause the ozone depletion. So CFCs are not only responsible for ozone depletion, but these are also greenhouse gases that are responsible for the global warming too. And yeah, I will talk about this later also. Okay, so what I was talking about is that the contribution of which gas is more for the warming. I have listed a lot of gases: CO2, CH4, H2O, SF6, N2O, CFCs. So can you tell me which gas is contributing the most for the warming? Yeah. So I got response that is CO2 and then water vapor. You are right. Then, okay. So what you are saying is that this is the gas that is mostly contributing to the warming, right? Now, my next question is which gas has more global warming potential? So I'm giving you one term, that is GWP, that is the global warming potential. Which gas has more global warming potential? Not CH4. Okay. So first you have to understand what is global warming potential. So it is like, so our reference gas is CO2. Okay. So let's say we have 1 kg of CO2, and if we are burning this, then there will for example, uh, if we have some fuel and if we are burning it, and that's how if we are getting 1 kg CO2, okay, then this 1 kg CO2 will give some warming, right? Let's say the warming is X, okay. Then if we are burning, if we have 1 kg methane, so this is approximately 21 to 24x. What does that mean? That the potential of methane uh, with reference to CO2 is 24 times more dangerous than CO2. So the potential of methane is 24 times more than CO2 potential for the warming. Okay. If I'm talking about this NO2, that is N2O, nitrous oxide, then this is nearly 275. But it is based on, are you calculating this global warming potential for 50 year or 100 year or 200 years? So value will be varying, but it is approximately near to 270. So what I can say is that if I have 1 kg of CO2, if I have 1 kg of methane and 1 kg of nitrous oxide, then nitrous oxide is 275 times more dangerous than CO2 in the perspective of warming. Okay, if I'm talking about this SF6, then this is in thousands. approximately 28,000 something. I don't remember exactly the magnitude, but the highest global warming potential that we have right now is of SF6. Okay, so that's why, and the global warming potential of CFCs are also in thousands. So that's why even if we have few gram of CFCs that has been released in the atmosphere, so can you imagine how harmful it is in the environment with reference to the CO2? And that's why there were a lot of protocols and conferences held, and that's how there is a lot of right now the alternative of CFCs that we are using. For example, HFCs we are using, then HCFCs we are using, and we try to phase out the CFCs so that the warming potential is very high, and the second is it has high ozone depletion. Okay, I got one question that please say full form of SF6. Oh, this is sulfur hexafluoride. This is sulfur hexafluoride. It has highest global warming potential. Okay, so no doubt overall, because we do have a lot of fossil fuel, because of that fossil fuel because of that combustion, a lot of CO2 has been released in the past, and that's why right now the warming is due to CO2 mainly. But the global warming potential of CO2 is right now the one, because the global warming potential of other gases are calculated based with reference to the CO2 only. Okay, so that's how the global warming potential of CO2 is one. uh, Methane is 24 25 times more than CO2, then nitrous oxide, this is 270 times more. SF6, this is in thousands, and CFC is also on thousands. So you need to remember all these things. Okay, the next question is, if you have any question, then you can ask me. The next question is, which of the following is presented as evidence of climate change? You have four options here: stable coastlines, rising temperatures, or reduced greenhouse gases, constant glacier areas. Okay, I think the option is very easy to select the right option, which is rising temperature. So, rising temperature is one of the evidence of climate change. A stable coastline is not. Reduced greenhouse, no. Greenhouse gases is increasing, and this is the evidence of climate change. Not climate change, but uh, it is triggering, it is the source of climate change actually. And constant glacier area, no. The glacier area is have been reducing, and this is again the evidence of climate change if the glacier area is reducing. So only correct option is rising temperature. Okay, the present era marked by significant human influence is called the Anthropocene, Holocene, Optimum, uh, Little Ice Age, Medieval period. Yeah, I think this option is also very easy to detect that this is Anthropocene. So you know that anthro means human, and Pocene, this is era, right? So this is the era that has been influenced by the human. So that's why right now the era 20 and 21st century, actually 21st century is a kind of Anthropocene era. Okay, Which set represents the three component of Milankovitch cycle shown in the lecture. I don't know you have seen that lecture or not, but yeah, we have three component of Milankovitch cycle, and you need to tell me what are these. So we have four option: pressure, humidity, and wind, rainfall, drought, and flood, precision, obliquity, and eccentricity, latitude, altitude, and vegetation. Okay, so I'm getting answer C, that is the right one. So, what are these and why these three processes are very important? And these are the part of Milankovitch cycle. And Milankovitch was a geographer in the past, and he gave this three terminology: precision, obliquity, and eccentricity. So, actually, there is a lot of debate on either the climate is changing, right? So the debate is on whether this climate change is induced by human or it is just the natural thing that is happening, because in the past also we had warm period, we had cold period. So there is a lot of debate, and on this climate change, what is triggering that climate change, either this is natural or this is anthropogenic. And Milankovitch gave three processes, that is the precision, obliquity, and eccentricity. These are the natural process by which there may be the climate change. Okay, so what are these? Let me show you. Okay, so if we see the eccentricity, so this is, it is changing the orbital path. So let's say initially it was like that. It may the orbital path may be like this over the time. So the distance of your Earth from the sun may be changed, right? If it is near to the sun, then we can say, okay, this is the warming situation. And if it is far from the sun, then it may be the cooling situation. So we can say that the climate change is maybe due to eccentricity. Okay, the first thing. The second is obliquity. Your tilt is also changing. The angle initially, it is varying between the angle 22.5 to 24.5, and that's how, if the angle is changing, then it means it can also give rise to the climate change. And the third is orbital precision, and this is how it is also changing the direction. Initially it was tilted like this, earth was tilted like this, and now it is like this. So this is your orbital precession, and because of that also climate may be changed. But the important point is that these are taking thousand of year, for example 21,000 of year, just for the change of 0.01 degree. Okay, but right now what is happening that in 1 century there is a change of 1 degree or 1.5 degree change. Right now what is happening? So the question is, the rate due to the natural phenomena are very less, but right now what we are experiencing is that the rate of climate change is very high. So this can't be just due to the natural things, but there must be some human influence that is triggering this climate change. And that's why we started to learn about greenhouse gases and their contribution to the global warming. Okay, the next question is, rising temperature and acidification are indicators associated with the, and I have four options: cryosphere, atmosphere, ocean, lithosphere. Rising temperature and acidification are indicator associated with the four option: cryosphere, atmosphere, ocean, lithosphere. Okay, so the answer will be C, that is ocean. Yeah, so the answer will be C. What is happening right now is that uh, if we have ocean here, and we have ocean water, and in that ocean water, if we have a lot of we have a lot of CO2 in the atmosphere, and then we have rising temperature in the atmosphere, and because of that, our ocean is also warming. And what will happen here? The CO2 concentration in ocean will increase. Okay, CO2 concentration in ocean will be increased, and that's how it will react with the water. So H2O plus CO2, that will give rise CO2, that will give rise to bicarbonate H2CO3, and then it can be changed into some HCO3 minus. It can be CO3 2 plus 2 minus, sorry. So we have carbonic acid. So if there will be a lot of CO2 in the ocean, it will increase the carbonic acid, and that's how your ocean will be acidified, because a lot of acid has been accumulated, and that's how acidification of the ocean is related to the rising temperature. So can you tell me what bad impact of this acidification will happen? There is the very prominent changes that is happening in the ocean due to ocean acidification. Can you write down that? If ocean water will be acidified, then what will happen? What will happen to the organism that are living in the ocean? Can you name me what will happen if there will be a lot of acid uh, in ocean, or the temperature will be rise? COD and BOD will be disturbed. Yeah, I agree that we have two terminology, that is COD and BOD. This is your chemical dissolved oxygen, and this is your biological uh, oxygen demand, and this is biological oxygen demand. So so this is something that because the terminology has been given by Kailash sir, so let me explain you first about this. Okay, so the thing is, for example, if we have ocean, and in ocean, uh, initially we had not much rising temperature, and because of that, oxygen in the ocean is near to, let's say, 9.1 mg of oxygen per liter. Okay, let's say we have 9.1 mg of oxygen per liter in the ocean. If there is a lot of rising temperature, then your oxygen will be gone from the ocean, right? Because there will be a lot of turbulence, and as we are increasing the temperature, your oxygen will be gone. Okay, the first thing. The second thing is, if we have a lot of CO2, then again there will be competition of this CO2 with the oxygen, then your oxygen will again reduced. So let's say after reduction, it is 7 mg per liter or 4 mg per liter. So but fish needs the oxygen to survive, right? And that's how if oxygen will be reduced, then this is something we will call as the biological oxygen demand. So this will initially dissolved oxygen was 9, it has been reduced to 7, then we have 2, that is 2 microgram per liter. This is biological oxygen demand. We need to flush more oxygen into your ocean, and if this will not happen, then fish will die out. Okay, so this is something. BOD COD is this is based on the how many how much oxygen we need for the organism, right? This is related to that. If we have COD, then this is chemical. So if we are putting a chemical, if we have okay, so the concept is something like that. If we have some carbon compound into some river, we will add some chemical to decompose it. Okay, so how much oxygen we need, how much oxygen the chemical need to decompose that substance will be your COD. Okay, and BOD is, you have any compound, carbon compound, let's say in the river, and you have organism, right? So organism will consume this compound. So how much oxygen we need to decompose that compound by organism, so this will be your BOD. But the thing is, BOD and COD are not much related to the ocean thing, because this BOD and COD is more related to the river and pollution. So what is happening, due to, let's say, if we have fertilizer company, and that fertilizer company is adding a lot of compound that is made up of nitrogen and, let's say, phosphate. Okay, and if that compound are being dumping in the river, right? So we have a lot of nutrients right now in the river, because this N and P are nothing but the nutrients, right? So right now we have a lot of nutrients in the river, and we also have some organism in the river. So how much oxygen is needed for the organism to take up all these nutrient, or to decompose it, the nutrients, into some very basic form? So this is BOD. This is not much related to the acidification. uh, okay, let me see. One person told me this salinity reduction. Yeah, so obviously, uh, if so this is very normal, right? If the acidification is happening, your pH will be reduced. Okay, your pH will be 3, 4, 5, or up to 6. Otherwise your pH will be higher of the ocean. So my question is, what will happen if pH is getting reduced? What will happen if pH is being reduced? What will happen if we have rising temperature in the ocean? Haven't you heard about coral bleaching? Have you heard about this coral bleaching? So in the ocean, we have organisms. So we have two organism, and these two organism combine, and we know these organism as coral. And these are very beautiful organism and shape you can see in the ocean, that is made up by this coral organism. And what will happen, these are very sensitive to the temperature and pH. Little change in the temperature and pH, what will happen, this coral will be died. And if the coral organism will be died, then the color of this color coral will be faded off and it will be something whitening, and that's why we are saying that this is the coral bleaching. So maybe in the picture and all you have seen very colorful colorful things under the ocean. This is what it is, coral. And with the change in temperature and ocean, there is because coral are dying off, and that's how the color is being changes to the fade one, the white one, and that's how this is known as the coral bleaching. So such kind of things have you seen in the ocean? So initially it was very colorful, but with a lot of CO2 and a lot of rising temperature, these are dying off, and that's how the color is getting faded. Okay, the next question is, in the ice albedo feedback, melting ice leads directly to greater surface reflection, lower atmospheric CO2, increased glacier formation, reduced surface albedo. Yeah. So I'm getting answer D from most of you. And this is reduced surface albedo. So if people are not aware of albedo, let me know you that sun is giving you short wave radiation, right? And if it will strike to the surface, then it will change into long wave radiation. And because of this long wave radiation only, there is a warming of the surface. This long wave radiation will warm the surface and to the air, and then it will go, and that's how this will warm the atmosphere. So this is long wave radiation. What is happening that if we have this sun, and let's say if we have here clouds, or here we have snow, so what will happen if your short wave radiation will come here? So it will reflect back in the form of short wave radiation only, okay, before reaching to the surface. So this is something, the reflection of short wave radiation is known as albedo, right? So if we do have clouds, clouds may also reflect your short wave radiation. And if you have snow here, then snow can also reflect it. Okay, so what will happen if ice are melting? Then what will happen? Your reflection will be reduced, and this is what it is, reduced surface albedo. And that's how there will be lot of trapping of energy will happen if ice is melting, because there is no reflection of short wave radiation, and that's how we will have surplus of energy that will give us the warming. Okay, so this is how the D answer is the right one. So this is something like that. If we have sun, and here it we have glacier, so what we are expecting that 85 to 90% of your sunlight will be reflected, just 10% will be absorbed. But if your glacier is melting, then this will expose your bare rocks, and there will be vegetation, something like that. And if such thing is happen, just 20% of your sunlight will be reflected, and a lot of 70% will be absorbed. Okay, so this is how there will be impact on reflection of short wave radiation, and the energy budget will be disturbed, and climate change will be happen because of this positive feedback. Okay, so now we are moving to climate extreme, and then we will take cases one by one of climate extreme. But before that, you must know, what do you mean by climate extreme? So, climate extremes are defined as significant deviation from average conditions, a normal seasonal temperature cycle, long term average without variability, event that occur every day. Okay, so I get two response, that is one A and C. A is the right one. Let me tell you why it is not C. So, for example, we have probability distribution graph. Mm, okay, so what we are seeing that initially, um, this was the mean. Let's say this is probability density function of temperature, right? And we are saying this is our mean temperature. Okay, so initially let's say mean temperature was 20, and now it has been changed to 22. So your mean temperature has been shifted to the upper side. It may be happen that it is like this also. This is also climate change, but not the warming. There may be the cooling due to the climate change also, but obviously this is not going to happen because we have a lot of CO2 and it will give us the warming. But cooling, whatever normal you have, so let's say the normal temperature we have is 20 degrees Celsius, but over time what we have observed that the mean temperature has been shifted to 22, let's say, and that's how this is known as the climate change. So this is something. We had the average condition was 20 degrees Celsius, and then there is some deviation from average condition because the deviation gave rise to 22 degrees Celsius temperature. So this is something the climate change, right? This is climate change, not right now the climate extreme. Then uh, then we are talking about the climate extreme. I have okay, so without variability, uh, 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 climate extreme is all about the change in the variability in a different way. So let me explain you with the three figures that I have. Okay, so the one is what will happen. First, what you need to understand, extreme condition are kind of rare things, right? So for example, initially we had this probability distribution function, right? This one, and here we had the mean, right? But right now what is happening is that your probability density function has been shifted to the right side, and now mean has increased. Now we have new mean of, let's say, temperature. Extremes are lying at the tail. Extremes are lying at the tail. So for example, if we have this probability distribution function, if we have this one, so this is mean, right? This is very obvious, this is very normal that it will happen. So let's say this is 20 degree Celsius temperature, that is normal for us. But this tail part, let's say this is -5 degree, and this tail part, this is, let's say, 45 degree. These are the extreme part, right? These are the extremes, what we call in the probability distribution function, the tails will classify the extreme. And if we are shifting this to the right, then what will happen? Initially initially this was initially this was our colder, but right now, sorry, this was our colder, but right now this one. So what we are having right now, we have less cold weather. But if you can see here, initially we had this and now this part. So with the time, if the mean is shifting to the right, then we will have less cold weather, but we will have more extreme hot weather. Okay, so this is what we have is the extreme events, or climate extreme. The next picture that I can show you is the increase in the variability. Here the variability was same. Right now here the variability has increased. uh, Here the variability has increased, more variation. So in that condition, we will have both more extreme cold and more extreme hot will happen. So um, in first condition, if we are just shifting the mean, if the temperature is increasing over the time, then we are expecting that we will have less cold weather, but we will have more extreme hot weather. But if the variability in your climate is more right now, then what will happen? It will give more cold weather as well as it will give more hot weather. Okay. The third case is change in the symmetry. It can also there may be shift in the mean and there may be shift in the variability. If both things are happen, then what we can say is that again there may be two cases. Then here also extreme cold we may experience and extreme hot weather we may experience. And it may be that your average, because it has been shifted to the left, then average there may be right now the average is little cooler side, but again there may be more extreme cold and hot weather. So this is how we can define our extreme climate extreme. I think you have understood. You can these figure are taken from IPCC, so anytime you can go to the website and you can see such figures. Uh, okay, so now we are going to solve the assignment question, which are not same but which are similar assignment question for this week too, and in which we will have different events that are related to the climate extreme. But before that, let me show you one thing. Um, if you can see my screen, and that let me show you how we can do this. So we can also see these climate extreme things using our temperature and precipitation data. So let me just copy it. So what I'm showing right now is we have IMD data from 1980 to 2014. This is for your mean temperature as well as for the precipitation. So right now I'm showing you how we can see the mean temperature data that has been given by IMD. So, so this is my data from 1980 to 2014. It is taking a little time, but I think it will be better to see. Okay. So, okay. So what you can see is here, let's say we have January data and it is from 1980. If I'm going here, This is showing me the February data. It is little slower. Yeah, it is February. So this is monthly data set. So monthly average temperature data from 1980 to 2014. So if we are like going higher, then what we will see that the color will be changed significantly. And we can also like we do have a lot of software by which we can extract such grids and such pixels where uh, we have extreme temperatures. So for example, um, so let's say this is again my data. And if I want to see where are the places where the temperature is more than 20 degrees Celsius or more than 30 degrees Celsius, so we have a lot of software. So let's say I the one software that we use is the COD, that is climate data operator. So and what I'm doing is whatever temperature I have below 20, I'm giving value to these kind of data to 0, and that's how I can see the pixels where I have temperature more than 0. So this is something that I'm setting the range, r is the range, to the constant. So let's say my temperature from -50 to 20, I'm giving 0 value. So what I'm telling to my software is that if I have value from range -50 to 20, give replace this value to the 0. So what will happen? Whatever value I will have more than 0 will be shown. Okay. So this is above 20 CNC. So this is how you can see the temperature or the area where the temperature we have is more than 20. Yeah. So can you see here? This is January, and in January, let me increase this. In January, this is you can see here also here. So in January, this is 0 value here because the temperature is less than 20. But here in the south part, my temperature is, here it is 22, here it is 22, here it is 22 again something. So this is here we have 25. So this is how we can this is how we can see where the temperature is more than 20 or more than 30. So there are a lot of software by which we can estimate um, uh, by which we can estimate the temperature. Let me again share you. Okay, so there are a lot of software. I think in the next few weeks we will let you know about this software and all. Okay, the one question is CDO open source? Yeah, CDO is open source. You can directly go to. Okay, the CDO you need to operate using the terminal. So yeah, it is open source and you can use it. And by CDO, by even with the ArcGIS and all, you can calculate this climate extreme, climate change, everything within a second. Okay, so now I'm going to the next question. The major characteristic of climate extreme is high probability, rare occurrence, low societal impact, regular timing. What is the major characteristic of climate extreme? Okay, so I got response that is B, that is rare occurrence. Yeah, you are right, because we already have talked about this, that we have probability distribution function here. So your extremes are defined in the tail. So these are your extremes, because this is happening, this is normal, this is mean, right? These are things that are happening rare. So that's how these are the extreme climate extreme. I give you one example, that if we are having the height of the person, and if we do have again probability distribution function of your height, then what we will learn, that near to 5.3 fit, we will have the mean value. Okay, of adult man, let's say the adult man 25, at the age of 25, the mean value is near to 5 feet 3 inch. Let's say, I'm just assuming it. Then at this end, it may be that few people, among lakhs and among thousands of people, there may be one or two people, the height of them will be near to 4.5, let's say. Or there may be some extreme where the height is more than 7 feet. Okay, so these are the extremes. These are the extremes. A lot of people, so this is the mean, a lot of people, let's say the thousands of people, the frequency of this mean is very high. The frequency of these at the tail are very low. So like this, we have temperature data, we have precipitation data, we have humidity data and all. Okay, so in which the mean is normal thing, right? It will happen every year. But at the tail of your probability distribution, this will show us the extreme, and this is very rare thing that is happening. But with the climate change, the frequency of this rare thing is also increasing, that we will learn in the next few slides. So this is the rare occurrence. The major characteristic of the climate extreme is rare occurrence. And if there is no rare occurrence, if it is like normal occurrence, then we will consider as the climate pattern only. It is the characteristic of the climate. But because it is rare, that's why we are calling it as the climate extreme. Okay, the next question is, permafrost though may strengthen climate feedback by releasing oxygen, nitrogen, methane, ozone. Oxygen, nitrogen, methane, ozone. We have glaciers, uh, we have permafrost, right? We have permafrost. If that permafrost are thawing, then what will happen? Yeah, I got some responses. I got C response from two students. That is methane. Yeah, you are correct. So what is happening is that uh, before glacier to be formed, there were a lot of organism. There were a lot of organism that are under your soil, right? That are under your soil. And because the temperature was very low, so it is not too much fossil, but there is, right now there is a lot of organisms, there is a lot of fossils we have beneath the permafrost. So if the permafrost will be thawing, okay, so if there will be no permafrost, then what will happen? So there is a lot of methane because of that fossils. A lot of methane will be released, and as I told you, global warming potential of methane is more than CO2. So can you imagine how much methane will be released in the atmosphere and how much warming it can give us. So this is again very scary picture, but yeah, this is possible, that if there is a lot of permafrost that is thawing, a lot of methane will come out from the soil and it will be released in the atmosphere, and the rate of the warming will be increased significantly. Okay. Now we have question that are MSQ, just like your assignment question. So this is multiple select questions. You need to select not only one option, you can select multiple. So that's how, please be aware of this, because this is multi select question, not multiple choice question. Okay. So, which surface temperature condition can strengthen unusually hot condition over land? And I have five options here: persistent atmospheric blocking, reduced evapotranspirative cooling, frequent passage of cold front, heat storage by built surfaces, strong daytime cloud development. So now we are moving little toward the heat wave, cold wave, uh, um, uh, and the cyclone. Yeah. So I got answer that are mostly A, B, D. Okay. So let me see. So it is something like that. Which surface atmosphere condition can strengthen unusual hot condition? Persistent atmospheric blocking. Yeah, this is the right one. In the heat wave right now happened in Europe. The one region was, it was the atmospheric blocking. Atmospheric blocking means it will create a kind of dome, and if there will be evaporation, then this evaporative air will not go up, it has to sink. If it is sinking, it means it is there is the atmosphere is blocking the evaporative wind, and that's how the your wind will be sink. Okay. And if there will be sinking air, then this will create the warming, because the cloud will not be formed, right? So this is happening. This happened actually 2 week ago only in Europe. Then the next is reduce evapotranspirative cooling. Yeah, this is again right. If there is no evaporative cooling, then again it can give you the hot condition. Can you give me the example when there will be reduced evapotranspirative cooling? Can you give me one scenario where we will have reduced evapotranspirative cooling? Okay, so one response I get is the rainy season. Yeah, indirectly you can say evapotranspirative cooling is dependent on the sunlight. Yeah, and if we will not have enough sunlight because of a lot of clouds and all, then what will happen? There will not be transpiration. Okay, so yeah, that's how evapotranspirative cooling may be reduced in the rainy season, because in rainy season we will have a lot of clouds, sunlight will not go directly on the surface, and that's how this will not lead to the evaporation. Yeah. One one answer I got is deforestation. Yeah. uh, this is again very important, that yeah, if we will not have forest, um, transpiration is done by forest, right? Transpiration is done by trees. So if we will not have trees, if there is a deforestation, then obviously there will be no transpiration, there will not be the water will be not be taken from the soil and it will not go to the atmosphere, and that's how there will be reduced evapotranspirative cooling. So yeah, deforestation is the perfect example to explain this. Then frequent passage of cold front. If there is the mass of cold air, then this will give you the cold condition, not hot condition. So this is not the right option. Then we have heat storage by built surface. Yeah. For example, in the cities, you must have heard the terminology that is urban heat island, and this is something that in the urban areas there is a lot of heat that is getting stored, and that's how um, if we are comparing this urban area to the rural area, then urban area are more warmer just due to a lot of multi-story building and the heat storage in that built surfaces. So this is again the right answer. This is right. This is right. Strong daytime cloud development. Cloud development will give you, as I told you, cloud is also giving you the reflection of your short wave radiation, and that's how this can give you the cooling things, right? So this is again not the right answer. So the right answer is A, B, D. Okay. The next question is, which conditions increase human heat stress during a prolonged hot period? And I have again five options: short exposure duration, weak ventilation, efficient sweat evaporation, warm nighttime temperature, high atmospheric humidity. Which condition will increase the human heat stress? When you will feel more heat stress that you have, in what condition? Let me see how many answers I got. I got B, D, E, D, E, and B, D, E. Okay, so let's see how this can happen. If you have so let's say first example, first option that we have is the short exposure duration. As we know, more exposure we will have, more heat stress we will have. So let's say if we are having just let's say if you are going to the city and the city have 45 degrees Celsius temperature, if you are just going for 1 minute, or if someone will say that you have to walk for 15 minutes, so 15 minute will give you more heat stress, right? So short exposure duration, no, this is not the right option. It should be long exposure duration. Then weak ventilation. Yeah, this is right. For example, you have switch on the fan or cooler. Let's say you have switch on the cooler, and if you are not opening your window, so what will happen? Cooler will give you a lot of humidity it may produce, and if there is a no ventilation, if you are not opening the window, then what will happen? This will create a lot of humidity, and again it can give you the heat stress. It will be better if you are opening the window and you are switching on the cooler, right? So weak ventilation will give you the human heat stress. C is efficient sweat evaporation. If time to time sweat is coming and sweating is evaporating, then this will give you the cooling, right? Because evaporation, the phase change is also always giving you the cooling. But what will happen if we do not have efficient sweat evaporation, if sweat is not able to evaporate, so there will be a lot of heat stress in your body. So uh, if it would be inefficient sweat evaporation, that would be human heat stress. But if it is efficient, then this is not the right option. Then warm nighttime temperature. Yeah, in nighttime what we are expecting is the cooling temperature to sleep, but if it is warm nighttime temperature, then obviously warming, either it is in the daytime or in the nighttime, it will give you the heat stress, right? So this will give you the heat stress. Then high atmospheric humidity, this is very important point. If we have same temperature, we have 30-degree temperature at one place, at another place also, and here the humidity is 80%, and in that place if humidity is 20%, then heat stress will be more in this condition where humidity is very high. Why? Because this is how this is creating weak ventilation and a weak or inefficient sweat evaporation. So if there will be a lot of humidity in your atmosphere, you're having sweating, but that sweating is not getting evaporated because there is no any gradient. Okay, so this is something that on your skin you have water, right? If your atmosphere is dry, then yeah, this water will be evaporated and will go away from your body. But if we have a lot of water, a lot of humidity in the atmosphere, then there is no gradient. Your water or the sweating that you have on the body will be intact. And that's how uh, high atmospheric humidity is giving you more human stress as comparison to the low humidity. So this is again the right option. So the options that are right is B, D, and E. If you have any query related to these right options, you can let me know, otherwise we can go further. Not just D and E, B is also the right option. Okay, coming to the next question, which processes can contribute to unusually cold surface conditions? Southward transport of polar air, strong nocturnal radiative heat loss, snow albedo feedback, persistent warm air advection, weakening or displacement of the polar vortex. Which condition can give you unusual cold surface condition? You can think over it and you can answer me accordingly. I'm just waiting for a few seconds more. Okay, so the answer is A, B, C, and E. Let me explain you why this is the case. Southward transport of polar air, you know that polar air are very colder in nature, right? Because of some disturbances, so let's say this is your earth, and here in this region We are expecting that we have a lot of polar air here, and because of that polar air we have cold temperature. But sometime, due to some disturbance, that polar air may go to the south, and this is how in the south part we may get cold surface condition. So this is the right one. Strong nocturnal radiative heat loss. So if we have heat loss in daytime, in the night time, then yeah, it will again give you the cold surface. Then what will happen? In what condition it can happen? If we have very transparent and if we have very clean air, when we have very clean sky with no cloud, then what will happen? Whatever radiation we have in the daytime, it will be released during the night time, and that's how there will be a lot of heat loss, because we do not have any cloud, we do not have any humidity. So this is how this can give you the cold surface condition. So this is again the right one. Snow albedo feedback. As I told you, in the mountain places, uh, because of that reflection of your shortwave radiation, there is a cooling, because there is no trapping of your surface energy, or the energy that you are getting from the sun, because it is getting reflected, and that's how we experience cold surface condition, just because of this snow albedo feedback. And then persistent warm air advection. No, this is not a correct one, because if we do have a lot of warm air, then this will give us the warm surface condition, not cold one. Weakening or displacement of the polar vortex. So just like this polar air that has been shifted to the south side, here, due to this polar air, at the pole there is the polar vortex, and if there is the polar vortex is displacing or weakening, or if it is a shifting to some other places, then it can give you the colder condition at that place where it has been shifted, right? So that's how A, B, C, and E are the right option. Sweta, do you want to say something, because you have raised your hand, so you can write in the chat box. Okay, now I'm going to the next question. That is, which outcomes are plausible during an intense cold spell? Frostbite, damage to power lines, livestock losses, improved crop production in all regions, and respiratory stress. I think this is the easy one to for the answer selection. What will happen if we will have intense cold spell? Okay. Rohit got very clever idea to give the answer. Then he told me accept D. So this is how he is accepting A, B, C, and E. So the clever idea. Yeah, I like it. No, I'm appreciating it. No need to say sorry. Anyway, okay. So what we are saying, that what will happen if there is cold spell? So cold spell is very low temperature. If we are getting for a long period, let's say for a week or for 3 or 5 days continuously, then what will happen? So uh, frostbite, yes, we can have frostbite because of the low temperature. Your skin may be damaged, right? Then damage to power lines, this is again possible. Why there may be damage to the power line? Why? This is again the right one. Then livestock losses. Again, livestocks are also organisms. So these organisms will also be affected, and that's how your animal husbandry will be affected. Improved crop production in all region. In some region it is okay, in some region crop production may improve, but not at all the regions, because we need enough sunlight for photosynthesis. So the cold spell may spoil or may degrade your crop production. Respiratory stress, yeah, because of cold spell you may have a lot of respiratory problem, from cold cough to a lot of. So okay, so I got one answer, that is the contraction of wires. Exactly. So we have a lot of electrical appliances that are based on our optimal temperature, and if we will not have that optimal temperature, then there may be thermal contraction and a lot of possibilities that we may have, and that's how there may be damage to the power lines. So except D, the right answers are A, B, C, and E. If you have any problem, you can write me in the chat box. Otherwise, we can go to the next question. Okay. So the next question is, which changes are expected as the background climate warm? So if there is a warming in the climate, what changes we are expecting? More severe hot streams, longer heat wave duration in many regions, greater cumulative heat exposure, complete disappearance of cold event, increased likelihood of very hot days. Yeah. So yes, except D, all answers are right. That are A, B, C, and E. And how it is? As I already have told you that, let's say this is your PDF, and with the time, it is shifting to the right side, right? Initially, your mean temperature was, let's say, 22, and now your mean temperature has been shifted to, let's say, 25-degree, right? So this is what we are saying, your background climate is warming. So with this, what will happen? More severe heat extremes. So initially, your tail was up to this point, right? Your tail was up to this point. Now your tail is up to this point. So let's say this was 45. Now let's say it is near to 50. So it means, because of your mean shift, because of that warming, what is happening, that you have more severe hot extreme. Initially your hot extreme was temperature was near to 45, let's say 47, but because your mean has shifted to the right side, so that's how your hot extreme will be more severe. So this is right answer. Longer heat wave duration in many regions. This may happen if your mean has shifted to the right, then there may be heat wave that can persist for more than 2 days, for more than 3 days, or it can be for a week. So the duration may be increased with your background warming condition. Then greater cumulative heat exposure, uh, uh, because right now, in place of 22 degrees Celsius, every day you are getting 25 degrees Celsius or 30 degrees Celsius. Then over the time, your heat exposure will be increased, and that's how this is the greater cumulative heat exposure. So this is again the right one. Complete disappearance of cold event. No doubt here it was cold event, initially this tail was cold event. Right now the cold event is this one. So no doubt your cold event has been reduced with the shift in the mean to the right side, but it is not like that it is the complete disappearance. There may be the appearance of cold extreme, but the frequency will be very low if it is shifted to the right. But along with that, there is the variability is also increasing, right? The variability is also increasing. So along with high temperature, along with severe hot extreme, we may also experiencing cold extreme also, because variability is also increasing. So it is not that we will have complete disappearance of cold extreme cold event. Maybe there is the less number if it is shifted to the right, but it is not complete disappearance. Increased likelihood of very hot days, as I told you here, the tail, it was initially near to the 40 degree. Now the tail has been shifted to, let's say, 50 degree. So this is something that we will have very hot days. So this is again the right one. Okay, which observation could be used to identify unusual intense precipitation? Daily rainfall above a high percentile, maximum 1 day rainfall, number of heavy rain days, gross domestic product, rainfall amount above a fixed threshold. How you will identify that this is very intense and very unusual precipitation? How you will identify that? There must be some indicator, there must be some indices. Based on that, you can identify. So let's say if you have today you have 10 mm of precipitation. On next day, let's say you have 22 mm of precipitation. Another day, let's say you have 35 mm of precipitation. Let's say here you have 15 mm of precipitation. So how you will, how you will get to know which one is the intense precipitation? It may be this one, it may be this one, or both, or it may be that all these 4 days we experience the intense precipitation. So how we will identify this? There must be some criteria, must be some indicator, there must be some indices, right? So the answer that I got is A, B, C, E. Okay. So yeah. So as I told you, to tell that, so for example, we have 0 mm. We 1 day we got 2 mm, another day we got 25 mm, another day we, let's say, we got 3 mm, and then 15 mm of the rainfall. So now we need to identify which one is the intense one, right? So how we will identify? We have two ways by which we can identify. The one is we have absolute threshold. So let's say if I'm in Bhopal and if I'm saying that if in a day, if it is more than 10 mm of precipitation, then it will be known as intense one. Just for the case, not very exactly. Okay, so this is, I'm giving very absolute precipitation value. Okay, so based on that, this 25 and this 15 will be considered as the intense rainfall or intense precipitation. Okay, based on my absolute value. The second one is based on percentile. Based on percentile, again, what I'm saying is that again I have one plot, and so this one is not the right one. um, so what I'm saying is that every day, so this is time, and I have time series, and here I have precipitation value, right? So each day I will have some precipitation, or it may be zero, it may be something like that. Okay, so what I'm doing is I'm calculating the 90th percentile of precipitation. So 95, above that 95th percentile, I'm assuming that there will be the extreme precipitation. Okay, because 50th percentile will be your median, right? Fifth percentile, we are considering that if the value of precipitation is below the fifth percentile, then we can call it as a drought condition. And if your precipitation is above the line of this 95th percentile, then we can call, let's say, it's the intense precipitation. So in this day, because here it is more than 95th percentile, we can consider that at that particular day there was extreme precipitation. So not only we can calculate this intense precipitation based on absolute, but we can also calculate based on percentile, and also based on your average. Let's say for 30 year we have average of 10 mm, and if it is more than 10 mm, then it will be known as the intense precipitation. Okay, so we have you heard about ETCCDI indices? ETCCDI indices. So let me show you. um, okay, so if you can see my screen, ETCCDI indices. Okay, so there are a lot of indices. Based on that, we can tell whether you have cold wave or heat wave, or you have drought, or you have flooding kind of condition, or precipitation extreme. So the one is number of frost days. So these are for the day. These are for the temperature right now. These are for the temperature. Let me go to the precipitation one. So there is a lot of indices. Yeah, so it started with month rx one day, so we can calculate this very easily. But this is monthly maximum one day temperature, one day precipitation. So in a month, what is the maximum amount of precipitation you get within a day? So let's say we have 30 days, and in 30 days we will get some precipitation. So what is the maximum amount in a day that we got in a month? So this will be rx one day. So this is the one indices that you can use. Then we have rx 5 day. So we have monthly maximum consecutive 5 day precipitation. So we will calculate the precipitation for the 5 days, and we will be running it with 5 day window, and that's how we will calculate the maximum in the 5 days. And based on that also we can calculate the intense precipitation. So this is again one indicator. Right now I'm not going to STII. Then this is based on your absolute value, as I told you, are 10 mm. So the days, we will count the number of days when your precipitation is more than 10 mm. So this is again one way. Then r 20 mm. So we can count the day when our precipitation is more than more than or equal to 20 mm. We have a lot of these maximum length of dry spells, and then maximum length of wet spell. This is based on percentile value. R95P tot. So this is total precipitation when your rainfall is more than 95th percentile, as I explained to you, right? So This is how we can calculate. um, Let me again going to see. So yeah, so this is how, based on that ETCCDI, you can search and you can learn more. ATCCDI is giving you a lot of indices. Based on that, you can calculate your intense precipitation, either based on absolute threshold or based on percentile. So 95th percentile, 99th percentile, based on 10 mm, 20 mm, 1 day rainfall, 2 day rainfall, 5 day rainfall. So likewise, we can identify unusual intense precipitation. So daily rainfall, as I told you, RX 1 day, maximum 1 day rainfall, then number of heavy rain days based on 10 mm or 20 mm, like this, rainfall amount above a fixed threshold. So there is a lot of way by which we can identify unusual intense precipitation, right? GDP is not the way to identify unusual intense precipitation. This is more related to the economics, not related to the climatology. Okay, which indices are commonly associated with precipitation extreme analysis? As I already have shown you, ETCCDI indices. So you can tell me which indices are more commonly associated with precipitation extreme analysis. RX 1 day, R95P, R10 mm, Pristot, Human Development Index. Yeah. The right answer is A, B, C, D. D is also one of the ETCCDI indices. Maybe I didn't show you, but this is total precipitation that we can calculate. So this is accumulated, not average. So we are summing up the precipitation, let's say over a year, and then we are seeing over year what was the accumulated precipitation that we had each year, and then we are comparing that one. So this will come under this precipitate. So this is total precipitation. So these are all ETCCI indices only. You can read about this. Human Development Index is obviously not the precipitation related index. Okay, which natural processes can initiate or worst the flooding? Intense rainfall, wetland restoration, snow melt, cyclonic storms, and storm surge. Which can make the flooding more dangerous? Yeah, so I got answer that are all the options except B, right? So, wetland restoration, wetland are very important as and has a lot of potential to accumulate a lot of water, right? And that's how this can help us whenever there is the flooding. So it can reduce the flooding level if we have a lot of wetland. But if we do not have wetland, then obviously it can worst the flooding situation. Intense rainfall, as I told you, if we will have intense rainfall, then uh, uh, there will be a lot of runoff, and that runoff will give you the flooding, right? Snow melt, if there will be a lot of snow melt, a lot of water will come on the surface from the glaciers, and that's how we can't manage that too much water in a very short period, and that's how this will even worst the flooding situation. Cyclonic storms. We have flooding, and if we will have storm, then it will again give you the rainfall, and it will again worsen the flooding situation. Storm surge. So because of a lot of disturbance in the ocean, the sea may be rise, and the sea level may be rise, and because of storm and all, and if the sea level is rising, a lot of water may come out on the plain area or on the surface in the cities, and that's how it can also worsen the flooding situation. So except B, all answers are right. Which human activities can increase flood exposure or runoff? Expansion of impervious surfaces, building across natural drainage paths, poor maintenance of drainage system, conservation of floodplain wetland, sediment accumulation in channels. What human activity will increase the case of runoff or flood exposure? Okay. So can I expect more answer from you people? Should I wait for a few minutes or few seconds only? Yeah. So thank you so much for replying. So the answer are A, B, C, and E. Let me tell you why. Expansion of impervious surfaces. So impervious surfaces are the concrete surfaces that right now we have. So if we will have everywhere, if we will have concrete surface, then uh, whatever water we will get from the atmosphere, there will be a lot of runoff, because uh, soil will not have the capacity to take it, right? There will not be percolation, there will not be infiltration, right? So all the water that we have on the concrete surface will go, and it will create the runoff condition and the flood exposure, because we do not have soil that can absorb that water, because everywhere we have concrete. So yeah, this will increase your flood exposure. Building across natural drainage path. If we have drainage path, if we do have some rivers, let's say, and river have some path, and all the water is going to that path, and after and at the end the water will go to the ocean. But in place of that in place of that bank, so river have some bank, and on that bank if we are having some buildings, then it can again create the runoff conditions, right? We have some buffer zone in the lateral side of the river, and if we are not maintaining that buffer zone, then again it can give you the more runoff and the flood exposure. Poor maintenance of drainage system. And the poor maintenance of drainage system, the one example is the sediment accumulation. So let's say we have river, and so in that river, if we are dumping a lot of things, let's say we are dumping a lot of sand into it, or let's say we are dumping a lot of organic thing, or let's say we are dumping a lot of leaf into the river, then what will happen? There will be a lot of sediment at the bottom of the river, and that's how the height of your river will be reduced, because at the bottom we have the sediment. So the capacity of your river will be reduced, and there will be more runoff and the flood exposure condition. Okay, I got something that sediment accumulation is regulated by natural causes mainly, and human play a very minimum role into that. So it should be natural. No, actually, right now, so. You are correct, but indirectly sediment accumulation right now is getting influenced by the human. So let me give you the example of the dam. So we once constructed the dam, and uh, with the time, so what is happening, if we are dumping a lot of things into that, and there is a sediment that is accumulated in this dam, and dam is the anthropogenic thing that we have constructed. And again, either it can reduce the lifetime of the dam, and it can also give rise the runoff. No doubt sedimentation is the natural thing, but yeah, human activity is also accumulating the sediment. So I will go with the D option also. And there is a lot of initiatives that government is taking to clear that sediment, right? So sediment accumulation is no doubt natural, but is also the anthropogenic influence. Okay, so the next question is, which component of the hydrological cycle can change during extreme rainfall? Surface runoff, infiltration, groundwater recharge, soil moisture storage, plate motion. Yeah. Um, can I get more answer from more audience? Okay, so the integrate part of hydrological cycle. So hydrological cycle means your water is coming from some places, it will go to some places, it will go to some places, and it will again go to the original place, right? So this is something that we have precipitation, whatever amount, let's say we have 100 of precipitation happened, right? Out of which some of your water will be evaporated. Let's say 50 of water is evaporated. uh, there may be that soil also absorbed some precipitation, and let's say now the soil moisture right now we got is soil also got, let's say, 10 of water. Then some of the water will not be taken up by the soil, it will be flushed out, and so this will be the part of your runoff, right? So let's say the runoff is 20 plus some of the water will be go to the groundwater, right? So what I'm saying is that the water is going from one place to another place, and then it is creating one cycle, right? Again, your evapotranspiration will give you the precipitation. Soil moisture, initially soil moisture will be stored into the soil, but the root will take up that water, and again it will evapotranspiration will happen, and it will give you the precipitation. So we have a lot of processes that will happen in the hydrological cycle, and the water will move from one place to the another place. So everything will be disturbed, but this will not. Plate motion is a very different thing. Plate motion, extreme rainfall will not have much impact on the plate motion, but because your water balance equation, if you will go to the water balance equation, these all things are under that water balance equation, so everything will be disturbed. Everything will be changed if we will have the extreme rainfall. What is infiltration? So infiltration is the soil is taking up the water. This is the process is infiltration. So penetration of water into the soil will be known as infiltration. Okay, the next question is, which consequences commonly follow severe floods? Displacement of communities, damage to infrastructure, guaranteed improvement of soil fertility, loss of life, contamination of water supplies. What will happen if we will have severe flood? The community has to move from one place to another, right? Damage to infrastructure, obviously a lot of infrastructure will be affected because of this severe flood. Guaranteed improvement of soil fertility, no. Why we can't expect the guaranteed improvement of soil fertility if we are having a lot of water into that? Because with the runoff, your topmost soil um maybe washed away. So soil fertility is mostly depend on the topmost soil, and if we will have a lot of flood, then the runoff will wash away this topmost soil, and this will be accumulated in any river, at last in the ocean, and that's how fertility may be reduced. Loss of life, yeah, we have seen that due to flood, people die and animal die. Contamination of water supplies, this is again possible because due to severe flood, there may be the ocean water may come to the cities, and then it can mix with your water supplies, and that's how it can also contaminate your water supplies. Except C, your answer is A, B, D, and E. Which effects may result from prolonged drought? Persistent increase in river discharge, crop failure, soil degradation, food insecurity, reduced water availability. Yeah. So, drought means we have less amount of rainfall, or we have less amount of water availability, right? So if we have less amount of water availability, then what will happen? Persistent increase in river discharge, no. If we will not have water, then how we will have a lot of river discharge? No, this is not the right option. Crop failure, we have seen this. India is too much dependent on the monsoon rainfall, and the crop is dependent on that only. And if we will not have much rainfall, then crop may get failure, right? Soil degradation, yeah, if we will not have enough moisture, we have a lot of organisms that are maintaining the health of the soil, and if we will not have water, the organism will be died, and that's how the fertility of the soil may be further degraded. Food insecurity, if we have no crop, then no food. Reduced water availability, if there is a drought, then how we will get the water in the dam or in the river? So yeah, it will reduce the water availability. So B, C, D, E. Now we are moving to the tropical cyclone. Which environmental condition favor tropical cyclone development? Warm ocean surface. Okay, one question. In drought condition, if soil had any impact, oh yeah, have you seen that you have soil, right? And if you will not have much water, in the soil, then first thing, there will be crack, right? There will be crack in the soil. And what will happen if there will be the crack in soil? Then the second thing, if we will not have soil moisture in the water, how there will be water that will be taken up by the plants? So there will be no plants if we will have drought condition for the long time. If no plants, it means that your soil will not be bound together. Soil particle will not be bounded together. It means your soil particles will be scattered, and if soil particle will be scattered, then your topmost fertile soil will also will be flush by air, or let's say water. No doubt there will be no water, but because of wind and all, your topmost soil will also be gone. Then we don't have soil moisture, then organism may also be die. That we have microorganism, I'm talking about bacteria, fungi and all. So all your flora, fauna, the health of the soil will be disturbed due to the drought. So drought have very direct impact on the soil. Okay, so what we were talking about is which environmental condition favor tropical cyclone development, and let me see the answers that I got. Um, A, B, D, E, A, B, A, B. Okay, so the answer is we should have a sufficient temperature of the ocean water, because for the cyclone to form, there must be moisture. For that moisture, it should be ocean, first thing. The second thing is moisture should go to the atmosphere, and before that there must be sufficient temperature, and that temperature is near to 27 or 26 degrees celsius, 26 or 27 degrees celsius. Okay, so we should have warm ocean surface. The second is sufficient Coriolis force, because cyclone is all about the circulation, right? And circulation is possible if we will have enough Coriolis force. Okay, so we should have sufficient Coriolis force. Cold surface water, no. Warm ocean surface we should have. The cold will not give rise to the moist air upward, right? Then we should have weak vertical wind shear. So if we will have strong wind shear, then it will not create a proper cyclone and it will not move, right? So we should have wind shear, but the vertical of wind shear should be weak, so that it can deflect, right? Then a pre-existing atmospheric circulation. Initially there will be low pressure, and then your wind will be deflected due to the Coriolis force and the weak wind shear. But to make that low pressure zone, there should be some atmospheric disturbances, right? And that's how it will form the tropical cyclone. So this is how A, B, D, E are the right answer. If you have any doubt among this option, you can let me know, and otherwise we can go to the next question. Okay, so the next question is, which feature belong to the organized structure of a mature tropical cyclone? Eye wall, strong wind shear, central low pressure, polar jet core. Okay, so I got one question that how low pressure is created. Okay, so low pressure is created mostly by the evaporation that we are having in the ocean. So this is uh, we have in the summertime, ocean will be warmed, and if ocean will be warmed, a lot of moist air will rise. Okay, so let's say if we have ocean here, and air will rise carrying the moisture, right? If it is going up, so here there will be low pressure, because the air is moving up, it is creating a void, creating a low pressure. And that's how there will be the low pressure. Okay, so let me see the answers that I have. Okay, A, B, C, D. As I told you, wind shear should not be the strong enough. It should be the weak wind shear. In the last question also, we wanted to have very weak vertical wind shear so that the Coriolis force can act and can deflect the wind. So if there will be a wind shear that is too much strong, so there will not be a particular sufficient circulation. So the wind shear should be there, but it should be weak. So that's how it should not be strong. At the center, there is the area that is known as eye. At the periphery of eye, we have eye wall. Then at the center, where we have eye, we have central low pressure zone. And polar jet core is a different thing. This is related to the polar, it is not related to the tropical cyclone, right? So the answer A, B, D are the right one. Okay, now going to the next question. Which hazards can accompany a landfalling tropical cyclone? Strong wind, heavy rainfall, storm surge, coastal and inland flooding, drought. Because of tropical cyclone, there may be landfall, and what condition or what things will should be happened with the tropical cyclone so that there is a landfall. So let me show you the answers. So these are A, B, C, D. A strong wind. Strong wind can give you the landfall. Heavy rainfall again will give you the landfall. Storm surge again will give you the landfall. Coastal and inland flooding we already have explained. Drought condition will not give you the landfall condition because for the land falling, the soil must be saturated so that it can fall, or there should be a lot of pressure. So drought accompanying with tropical cyclone can't give you the landfall in most of the condition. Okay, which impacts may occur after a severe tropical cyclone? Coastal erosion, glacier formation, landslides in steep terrain, infrastructure damage, saltwater contamination. Remember that due to severe tropical cyclone, there will be a lot of rainfall. And what will happen if there will be a lot of rainfall on the land part? B is not the right answer. Glacier formation can't be happen with the tropical cyclone. If we have a lot of rainfall, then is not giving you the glacier formation. Snowfall may give you the a lot of glacier formation. So this is A, C, D, E. Just think that tropical cyclone will bring a lot of rainfall, and because of that rainfall, coastal erosion may happen, landslide may happen, infrastructure may be damaged, and because ocean water may come to the surface, to the land, and that's how saltwater contamination may happen. Then, which cyclone related changes are consistent with warming climate? I'm just trying to, okay. So I think the time is up, but Um, let me finish 20 question, and then we will go to have a dinner, or you can go anywhere. So we are quickly completing this 20 question. So which cyclone related changes are consistent with warming climate? So let me give you the answer. So greater rainfall intensity, obviously cyclone will bring a lot of rainfall. Increase intensity of the strongest storms. Cyclone will bring again a lot of storms. Then warmer ocean surfaces. If we have cyclone, and the cyclone are consistent with a warming climate, then obviously your ocean surface will be warmer. And more high category storm in some projections. We may expect a lot of storms at different locations. For example, you have seen that in Odisha and sometime near to the Gujarat, we have such storm conditions due to the cyclonic condition. Weakening of earth rotation, there is a no role with the earth. This is more geology rather than climatology. Which action can reduce loss of life from a tropical cyclone? So a timely early warning, yeah, this is important. If IMD is giving you the timely early warning, then we can prepare ourselves before tropical cyclone, as we did in this in Odisha and all. There is a 2 or 3 day pre warning that is issued, and that's how this can help to prevent any loss. Clearly marked evacuation routes, yeah, this is also happen. And this also reduce loss of life. Cyclone shelter, yes, this can also reduce. Risk sensitive coastal planning, this is a little tricky one. And the removal of protective mangroves, if we are removing the protective mangroves, then this will increase the loss of life. Yeah, so except E, all answer are right. Which hazard can be intensified by urban development? If we have a lot of buildings, then what will happen? Heat stress during heat waves, yeah, there will be a lot, because a lot of heat will be stored within that buildings, right? Tropical cyclone formation over land. This is not related to the urban development. This is about the atmospheric circulation and the ocean warming. So this is not related to the cyclone. Water logging, a lot of concrete things we will have, water will be logged. Urban runoff, again, concrete will give rise to a lot of runoff. Rapid surface flooding, if there is a runoff, then it may bring flooding condition in the urban areas. Then which interaction help connect climate variability with extreme event? So which interaction help connect? So we have climate variability. Sometime we have summertime we have winter, sometime we have rainfall, sometime we have high temperature, low temperature. But how what interaction help to connect this with the extreme events? So ocean atmospheric coupling important. The monsoon part and the tropical part we learned. Ocean atmosphere coupling, land atmosphere feedback. Monsoon is the one type of land atmosphere feedback. Snow ice albedo, we have learned about this. Change in radiative balance. So this is at the top of the atmosphere. How much radiation is going and how much is coming. So if we are subtracting it, then this is something we known as the radiative forcing. So there will be change. If there is a change, then this change can give you the warming or cooling based on whether your radiative forcing is negative or positive. Plate tectonic motion, no, this is not much related to that. So yeah, ABCD. So these are the 20 questions that were related to the 20 questions that we have given in the assignment. So I hope that you will solve the assignment questions that are given online. So, and thank you so much. Along with that questions, I have more questions related to heat wave, cold wave, and definitions of this. I think we will solve these questions in next week. And till then, happy reading, and have a nice weekend and nice week ahead. So thank you so much. Um, you can leave the call right now. So thank you so much. If you have any query, you can just let me know, or I can give you my email, so you can send me anytime any questions, and I will be ready to give you the answer. And if you have any suggestion, you can just let me know how I can improve the teaching part. Okay, the one question is why the cyclone lost its power when it reach in land, because the moisture connection is cut off, because all the moisture is coming from the ocean, and if land is not giving you the moisture, so on the land, if we don't have the moisture, so the cut of the moisture will lost its power, because all it its power was due to the latent heat and due to the moisture rising. And the second is you have frictional force, right? Because of that friction, your wind will reduce its speed also. So these are the two basic. The one is very important. This is the moisture cutoff. This is important, and indirectly one is the gravitational, the inner the resistance that will be given by the land. So this is how the cyclone lost its power when it reached inland. Any questions?